let's start our next session on financing solutions for sustainable buildings. And we are going to turn to one of the central questions for scaling. How can sustainable cooling solutions actually be financed? And with that question, I'm going to hand over to you, Malin Emmerich, who works with GIZ Pro Klima, to give us an introduction to this session. Hey, Malin.
Hi, Julika. Thank you very much. Good to see everybody back after this technical stress hiccup. So, as you all know, this session focuses on financing solution for the transition towards sustainable cooling. From my perspective, one of the main barriers to accessing financing for cooling is the language barrier. What I mean with this is that companies and governments looking to finance sustainable cooling often approach potential investors and financial institutions with their technical solutions, thinking that a good technical solutions automatically makes a financially viable business case. This is rarely the case. And that is what I mean with a language barrier. Project developer talks about energy efficiency, safety issues, R290 solutions, but often the financing partner need to hear return on investment, guarantees, and risk mitigation to commit to the project. A technically and sound and safe project is not automatically bankable. But the good news is that there are a range of financial instruments and business model available. Knowledge about these instruments and the financing language makes it easier, but not easy, to overcome this barrier and identify financing instruments for sustainable cooling. And that is what I hope we will do today. First, Assad Nissar, private sector development specialist at the International Finance Corporation at the World Bank Group, will give us a glimpse of the width of financial instruments already available for sustainable cooling. After that, Luiza Linton will introduce green financing taxonomies to us. And for me, taxonomies are similar to Google Translator. It's a tool creating a common language. So very suitable for this session. But I leave it to Luiza to go into the details. Concluding the session, Samuel Jacobs will present cooling as a service. Servitization is a business model which enables profitable, sustainable cooling without capex or financial risk for the end user. So stay tuned to find out more. And with this, I hope to have set the scene for the session and hand over to Assad directly for the first presentation. Assad, the floor is yours.
Thank you very much. Good to see you too. And thank you, Julika.
Yes, everything is perfect.
Super. Thank you very much, Julika. Good morning, good afternoon, everyone. I'm Assad Nissar. I'm with the International Finance Corporation, World Bank Group. It's the private sector arm of the World Bank Group. I'm currently based in Lagos, Nigeria, covering Northwest and Central Africa. I listened to some of the colleagues discuss R290 and natural refrigerants. I will not focus on the technology itself, but I will rather go to the layer underneath, which is the money, financing. Because no refrigerant transition and scale would happen without financing flowing to the people deploying the technology. Next slide, please. So let me start with the size of the prize. IFC and UNIT partnered to do a report on cooler finance. If you haven't seen it yet, please download a copy, read, and do give us your feedback. In this report, we estimated the current size of sustainable cooling, currently around $300 billion, but projected to grow to $600 billion by 2050. Where does this growth come from? predominantly from Africa, 7 times the market is expected to grow, and South Asia 4 times. But of course, globally, the demand for cooling is going to increase, unfortunately, because of the climate change. Now, it's not just the size, but also the value that sustainable cooling is creating. In the next 25 years, the potential of cost saving for consumers is approximately $5.6 trillion. And for governments or countries that they want to meet the growing demand for energy, the cost saving could be $1.8 trillion. Very briefly, what does that mean? So one of the countries I cover right now is Nigeria. And we have a flagship program of World Bank Group and African Development Bank called Mission 300, connecting 300 million people in the sub-Saharan Africa to electricity and energy. Nigeria is one of the biggest markets. Approximately 90 million people lack access to quality energy. In parallel to this, while this continues, we also did another study to look into where does the energy go. Over 50% of the energy consumption goes into cooling. So on the one hand, yes, we should focus on generating more, improving the quality of grids and transmitting more, and improving the quality of distribution to avoid any losses. But in the meantime, what if we do saving? What if instead of burning 50% of the energy generated for cooling because of outdated technology, switch that to sustainable cooling, and the saving could be up to 90%. So that's just one example, and I will not go into more details there. Here is another contradiction, though. While this market is this large, still the estimated need for financing is between $400 to $800 billion just to close this demand gap. The money is not flowing the way it should flow. Or in other words, cooling is the largest invisible market in climate finance. And that's a problem I want to focus on. Next slide, please. So why finance isn't flying? 4 problems. Number one, cooling is hard to identify. It sits in a structural blind spot for lenders and investors to identify it. It's hard to identify. What does it mean? It means when we approach a financial institutions or financier, we ask for financing for a housing project, for a building, for an infrastructure project, for agriculture, value chain, so on and so forth. We don't ask the financing for cooling itself. It's always hiding underneath something else. The second challenge is it's hard to isolate cooling. If we compare it with solar, for instance, solar, you understand that there are panels and these panels on rooftops, but mostly the technology for cooling sits somewhere within a chain or a building or the value chain itself or a cold storage somewhere. It's hard to track. Companies often self-fund or finance the improvement of cooling needs, or they bundle them again, as I discussed initially, under a larger contract or investment project. And then finally, it's hard to secure. So what is the reason? The result, a market that is growing 7 times in Africa, 4 times in South Asia. Globally, it's going to be $600 billion. it's invisible. Financial system doesn't know it. And let me give you one last example on that. In the temperature controlled logistics, or when an applicant goes to the bank and asks to finance a reefer truck, a refrigerated truck, the value of a reefer truck is 2-3 times higher than an ordinary truck. What the bank does mostly, this is not a universal, but mostly in low and middle income or low and middle income countries, they do not have the residual value models for a reefer truck. So they view it as an ordinary truck. And that value of financing that you need for it, it just diminishes because you need, for example, 60K and you get only 20. Because bank also tries to calculate that if there is a default, how am I going to sell this truck in a secondary market? So that's just one example, but we have a lot of these cases. Next slide. So what are we doing at World Bank Group? We have a 5x5 plan. We have 5 engagement pillars held together with one principle, and that's innovation in financial and business models. And then it focuses on 5 sectors where cooling demand is rising the fastest. It's buildings, manufacturing, agribusiness, cold chains, health and education, and transportation. Our response is insights, which is mostly thought leadership, influencing, innovation and supporting innovation, direct investments, and as Malin mentioned, through different instruments, and then the impact that we want to create. I'll be happy to discuss these other interventions if you're interested, but due to time limitation, I will only focus on investment in the next couple of slides. So these are some of the case studies and examples of where IFC invested. We did Brookfield REIT in India, a $350 million finance package. Again, the objective being cooling, but we had to put it under age advanced, which means a 40% efficiency improvement. The way we supported our transaction included a TA component, or technical assistance, as well as direct investments to the company. The second here in the case study is also in India. It's $100 million for a housing developer. Again, the developer committed to age advanced, and our financing included a TA component, technical assistance, but it was financed under our GRIP program for real estate portfolio reviews. You also see an investment in Brazil. This is slightly different from green buildings. Excuse me.
I'm sorry, somebody
no problems.
has not muted the mic. Just proceed.
That's fine. So in Brazil, we did a $125 million investment. It is with an organic chicken farm, scaling 10 times to 200,000 birds. We are providing technical assistance as well as financing for cooling for chicken sheds. It's basically our partner is preparing to adapt to the rising heat and improve their current cold chain logistics. An example also in Ukraine, it is part of a broader package of investment, a $400 million deal for Agri-Europe. The company is a large agri conglomerate, and their cooling needs are across entire value chain. So we also need to keep in mind globally, but also in the context of low and middle countries, a very high percentage of food is going to waste. And 30, 40%, in some countries up to 50%. So this was also something that we include. Next slide, we talk about how IFC is connecting innovators with adopters. One of our programs that concluded recently was Tech Emerge with support of UK government. We implemented in several countries, including the country I'm based in right now. Coolbox Nigeria, for example, is one of those examples, and it is very relevant to this event today. It is a company that specializes in building solar-powered freezers for SMEs and residential users. It's completely off-grid, and the financing model that we supported them, but now they are connecting with local financing institutions. It's pay-as-you-go. But in the same light, we are also exploring two new products that we're pushing. I mean, this is not the innovation of products, but we are just trying to fit it for purpose. One is a sale leaseback option, because most of these companies, they carry a lot of asset on their balance sheets because of the pay-as-you-go model. So in order to release some of this pressure from the balance sheet, we are working with some financial institutions to engage in a sale leaseback product, which means the ownership of the asset will transfer to the financial institution on paper, while the cooling as a service provider continues to operate and maintain the equipment on a lease-to-own or arrangement. And then they could sublease this to consumers. It can be SMEs or other household consumers. We also have a case in India and Mexico. It's it's a chilled carbon dioxide.
Assad,
yes.
Assad, let me interrupt you. I want to give the participants a chance to ask their questions directly. And since we are sharing all the presentations afterwards, maybe we can come to an end to your presentation.
Thank you, Julie. Last slide, please. It's a call for action. So what needs to happen? For policymakers, we had the example of Kenya. That's when I joined, and I saw Kenya has adopted MIPS, as well as some other policies. So we need to adopt cooling taxonomies, develop these labels, and adopt MIPS policies, as well as other supporting regulations that could classify efficient appliances as eligible assets for financing. For financiers, we need to scale blended financing as well as concessional capital, because one of the most important factors in the context of low and middle economy in emerging markets is de-risking. It's a new market for most of these financial institutions, and we could step in to de-risk and provide blended financing to make it more attractive and lower some of the costs. And finally, for the entire ecosystem, we need to build on the global cooling pledge to establish cooling finance partnership. Let me close with this last line. The research exists, the technology is proven, we are using this, the model works, and we have proven this across the world. The missing piece is collective action and bringing these parties together. Thank you very much. Over to you.
Thank you very much, Assad, for that really interesting presentation. And dear participants, feel free, use the chat, ask your question, highlight the question you want to be answered, okay? We are doing our best to answer them in the chat or in our Q&A session that will follow at the end of this session. Thank you once again, Assad, for your presentation. And let's hand over to our next speaker, Luiza Linton, who is Managing Director at agradblue, and she's responsible for transition planning and carbon credits at agradblue. And she is going to talk about green and sustainable finance taxonomies. Welcome, Luiza. The floor is yours.
And thank you, Julika, for the friendly introduction. Pleasure to be here today and talk to you about taxonomies. And Assad has given me the perfect way of attaching my input today to his input. Then one of his last bullets on his final slide was that we need taxonomies that define what cooling solutions are actually sustainable, and we need that in order to channel scarce capital towards sustainable cooling, and that's what I want to have a look at today. Next slide, please. And first of all, we need to have a look at a wee paradigm shift then, because if we want to look at the financial sector together with sustainability, then we need to define a new role for the financial sector. Next slide, please. And that is because we need a lot more capital for sustainable solutions. And Assad had the more detailed numbers for cooling. I've brought with me the global clean energy investment needs that we have to achieve net zero by 2050. The International Energy Agency estimates that we need 4.5 trillion US dollars per year. We see that currently we are investing roughly half of that every year, and we need to fill that annual gap of clean energy investments that we need to achieve net zero in the future. And that roughly matches Assad's number that also showed that we need to double the capital flowing towards sustainable cooling solutions. And we have a huge gap, and we have a financial sector, a private financial sector with a huge task at hand. But for them to fulfill their task, we need to think about the financial sector differently than we did before. And we see that on the next slide. That was right. And on the left, we see the original, the old school way of thinking of the financial sector. The financial institutions are intermediaries. They take the savings of the savers and decide where to give that capital, allocate that capital to the real economy, to businesses, to homeowners, and they decide that based purely on financials. Malin said at the start, it is important to speak the financial language. This is the original financial language: returns on investments, bankability, what are my risks? And the financial sector gives that capital when the financials are right, most of the time ignoring all the sustainability impacts and risks that occur in the real economy with that capital. So in order to discuss how the financial sector in general can play a new role in our economy and help shape the sustainable economy of the future, we enter the world of sustainable finance. And you see that on the right, where the relationship has changed. Financial institutions no longer provide debt and equity to the real economy based purely on financials, but they also look at the sustainability performance of an undertaking. They look at the sustainability risks and opportunities, but also at the sustainability impact. So, for example, the global warming potential of a cooling agent, which also means the real economy needs to provide data on sustainability, or else a bank, an investor cannot judge, is this really a sustainable solution that I'm financing? And this is where the link comes to cooling. Let's have a look in particular at taxonomies in the next chapter, and how they can play a role in channeling capital towards sustainable cooling. Next slide, please. So we will dive in here and we can go to the next slide. again. And first of all, we need to have a look at the problem that taxonomies address, because we see we saw now, okay, we need capital for more sustainable solutions to finance the transformation that the world has to go through. But when the financial sector started to look at sustainability and green investments at the time, or green financing, green was not defined. The initial start was in the with the green bonds, the green bond market, and everybody said, okay, this is green, that is green, and it was a little bit of random, if you like. Market participants and thought about what can be green, but eventually the regulator thought, well, actually it would be good if us as the regulators define what is green, because we in the banks, say if you think about the classical bank, we have technical staff there that can judge the financial side of a project, but they do not have the technical engineering capabilities to assess the sustainability of an AC system. So that's why we need the solution, the taxonomy on the right. What does a taxonomy do? It creates a classification system where it goes sector by sector and defines the threshold of what is sustainable and what is not sustainable. Sometimes they also classify what is a transition technology, thereby creating in a result most of the time binary system where we have a technology, we have an AC system, for example, and either that AC is sustainable or it is not sustainable according to whatever taxonomy we're looking at. And that creates a clear signal to the financial sector that a certain technology is sustainable. They have the transparency about that and know, okay, I'm doing a good thing here. I'm really financing or investing in the sustainable solution, and I'm playing my part in this new paradigm of the role of the financial sector in the transformation. Taxonomies most of the times reflect the best available technology that we have, so they need to be updated as technology evolves. Then also the criteria become more ambitious. And a very, very important note, because that is always a point of confusion when it comes to taxonomies. They do not prescribe that you have to only invest in the sustainable activities. They merely classify. It is a transparency tool, a classification system, a reporting system, if you like, but it is most of the time not prescriptive. So it is not. It doesn't prohibit anybody from investing or financing non-sustainable solutions. Next slide, please. So most taxonomies follow a certain set of steps of how to check for a sustainable activity, inspired by the EU taxonomy, which went through a very large consultative process to develop this. And first of all, you check for eligibility. Not all economic activities are found in most taxonomies because they look at the worst, say the worst sectors first. Say, for example, they look at the thresholds for 80% of the emissions of the entire economy. They won't classify very nitty-gritty, not so relevant emission sources. So first of all, is the economic activity that I'm looking at in the taxonomy at all? Yes or no? Then it is eligible. For example, are ACs, are cooling agents in the taxonomy? Yes or no? If they are, then I move to the second step and I check the threshold. Is there, for example, a global warming potential limit? For example, the EU has 675 for heat pumps. And do I match this criteria? Yes, well, then I have a substantial contribution to, for example, climate change. Next, I need to check that I'm not significantly harming other environmental goals. To make an example, I cannot have a highly energy efficient building but have a lot of waste that I dump in the environment around the building, thereby adding to pollution. So I also need to make sure that I'm not harming other sustainability goals. And in the end, I also need to maintain minimum social safeguards. I cannot pursue an environmental goal and in the process not meet labor rights, human rights. So yes, I'm pursuing an environmental goal, but I'm also not harming people in the process. And if all these four criteria are set, then yes, I have a sustainable solution. and I can give the signal to the bank, to the investor, and say, hey, the project I'm doing is sustainable according to this taxonomy. Next slide, please. And let's have a look at an example, because that makes it always a little easier to look at, and how the taxonomy fits into the broader context of the Montreal Protocol that most of you in the room work within. We have the Montreal Protocol demanding the HFC phase down. We need alternatives in the industry so that phase down can actually happen. So we're looking at R290, and we have an investment gap. We need capital to actually finance the transition to those low GWP solutions. And that's where the taxonomy comes in. It defines what is green. It sets the threshold for the global warming potential and the do no significant harm criteria. And then capital can, in an ideal world, of course, flow towards these sustainable cooling solutions, and one can tap into ESG funds, green bonds, or even like cheaper credit. We have a lot of scientific work looking into the cost of capital for sustainable solutions, and we're seeing evidence that you can actually access cheaper credit through sustainable solutions with a signal like a taxonomy compliance. And as an example, if you have a building that is being retrofitted and including a new cooling system with a global warming potential of less than 675, which is, for example, the thresholds the EU taxonomy has included for heat pumps, and then one can access credit, enter ESG labeled bond markets, qualify for green loans, for example, and also be put into sustainability focused investment funds, ideally reducing the cost of capital for the project. Next slide, please. And I've had a look at an example. Bear with me, I'm not a technical engineering person, I'm an economist, so you a lot in the room have a lot more technical knowledge than me, but I've brought with me an example, and from my research, the most detailed taxonomy out there is the Australian one when it comes to cooling and the global warming potentials of ACs. And I've brought with me this one as an example. First of all, what industry are we looking at? And a taxonomy always firstly defines the activity that we're looking at. And here the criteria are found in the manufacture of equipment for buildings. So it does not only look at ACs, but in general, all the equipment for buildings. And we're looking at climate change mitigation, the objective of climate change mitigation, and thresholds of when does an equipment actually pay into the climate change goal of, in this way, Australia. And here they have the different equipments listed, but most of all they have the global warming potential listed in this table 14, where they look at the thresholds over time until 2035, which become more ambitious over time, which is in line then with, say, a net zero climate target, where we also see that we have to become more ambitious and more energy efficient over time. And that's just an example, because that takes me to my takeaways on the next slide. Why am I telling you all this? Because you can play a role in forming taxonomies worldwide, and including R290 and the thresholds and taxonomies, because as Assad has already mentioned, cooling is always like mingled in a whole building and a larger infrastructure. So, which is why I also struggle to find more detailed or more thresholds, because a few taxonomies actually are looking at this in much detail. We see that the capital is there in the market. We need to direct it correctly to sustainable solutions, including cooling. You can think of sustainable taxonomies as the pipes that are directing capital towards the right solutions. And now very few taxonomies are very explicit with cooling criteria. And from our view here today, that must change. And you in the room hold the key data to actually have the technical criteria included in the different sustainability taxonomies in your region or country. And this is where I conclude. Thank you so much for your attention. And I am interested or I am looking forward to your questions, and my contact details are on the slide for anybody interested.
Thank you so much, Luiza, for your presentation. And I see that, yes, there are some questions in the chat. Just make sure to address them, okay? So if you have a question to Luiza, just let us know that is a question for Luiza, okay? Luiza, thank you very much for your presentation. And now we are going to talk about the servitization as an instrument for scale. And I would like to welcome Samuel Jacobs to join me. And he is from Energy Partners Refrigeration and is executive head of business development and chairperson of COPA. Hey Samuel, good to see you. I'm just going to hand over the floor to you.
Thank you, Julika. Yeah, pleasure to be here, everyone. Good afternoon from South Africa. Yeah, to everyone wherever you are in the world right now. Yeah, so let's jump in. So I'm going to be talking about servitization. My colleague Assad has actually had it on some of his slides. In industry, it's known as cooling as a service, but servitization is essentially the idea that a manufacturer no longer sells a piece of equipment to an end user, but that the manufacturer retains ownership of that equipment and sells the service that equipment provides, and that's where the word servitization comes from. So we'll look at servitization as an instrument for scale within this R290 industry that we're talking about. Next slide, please. All right, so I think to set the scene, the first thing to think about, at least in my mind, when we think about development finance aim is really to transform the market, to shift the market from, in this case, from synthetic refrigerants to natural refrigerants, and specifically in this case to R290. But that's really the aim of development finance, is to start seeing market transformation. So I've sketched out here a very simple linear model. In reality, development finance is a lot more complex than what I've sketched out here. There's interleading loops with regulation and policy formations and a whole bunch of other stakeholders, but I thought I'd keep it simple and linear, and really to show you that there's always a development challenge that is started off with, like, what is happening in the market, how is it impacting our society or our planet. And then between that development challenge and the market shift is the space which in development finance plays an active role. So it looks at investable opportunities. It looks at prioritizing and targeting. How can it zoom in towards where the action really is? And then it assists in setting up demonstration projects for technologies that can be deployed to help solve the development challenge. And then the next step is, how do we scale from development projects across the market, so that we ultimately can see a shift in the market. So that's sort of the architecture around it. In the background there, we sketched a young property developer. She owns a portfolio of buildings in some city. And if I can borrow a little bit from Luiza's presentation as well, in terms of green finance. So she, this character that we sketched in here, wants to expand her portfolio. She wants to add another building to her current portfolio of hotels and shopping centers and hospitals. But she she wants green finance to make the credit more affordable, but her portfolio is not green. She's got synthetic refrigerants everywhere on her buildings, and now she knows she needs to start transitioning. But as she starts looking at the data, it becomes extremely complex. She's got multiple service providers over various buildings, various levels of performance of these systems. And then she looks at the cost of transitioning to natural refrigerants, which is quite high. And what happens is that it starts to feel very complex. And she knows that she has to do that, but the time she's going to have to spend in project managing this and making sure that the long-term risks are all covered really just generates a high level of complexity for her, and she can recognize the risk with that as well. And what that does is it immobilizes her. She wants to do the right thing, but she just can't get going. There's so much complexity ahead. And so we introduce servitization, this concept that she can partner with someone that can help her through this journey and make it a little bit easier for her. Next slide, please. So you'll see there servitization slots in that instruments for scale section that I sketched out in this linear model. And the aim of servitization really is to transfer the risk and the complexity to a long-term partner. So somebody that's going to be with our property developer in our sketch here over a 10-15 year period, really to grow with her and help her go from one building to the next in transitioning her to natural refrigerants. Next slide. You can press next again. Right, so let's look at what she's facing here. So the first thing she's facing is high upfront capital costs. The new technologies costs a lot. She has to take it on a balance sheet. Can she afford it? What is the long-term return on investment going to look for her? So there's a steep hurdle for her to overcome. She looks at the operational and technological complexity of the new technologies. Does she have the right staff to look after these systems as she introduces them onto her buildings? She understands there's long-term performance risk, because even though you put new equipment down, when they perform today, they have to also perform tomorrow and the day after and the day after. So who's going to ensure that that happens? She's concerned about the skill sets in the market. Are there enough technicians that's going to help her maintain this equipment into the future? And then, of course, she looks at her own internal resources. She's a property developer. She wants to get the next building. She wants to go and apply for funding for the next building. But adding this technology to her building will put a drain on her resources as she has to focus on it. So what she decides to do, she heard about servitization. She reaches out to a manufacturer who's willing to retain the equipment as their own and only sell the cooling to her as a service. And so she partners with someone who will take up the high upfront capital costs on their balance sheet, somebody who will take the operational and technological complexity away from her and really keep it on their side and just sell the cooling to her, someone who will partner with her in the long term, not just today, but over a long period of time, that she can go from one building to the next with someone who's with her on the ground. And then someone that will, of course, free up her resources, as that person will focus on the efficiency of the systems. She signs a deal with that person. Her hands are freed from the complexity, and now she can focus on developing a property. She can go and get the finance that she needs from funders. And all of a sudden, the cooling is optimized by a long-term partner. She's seeing the energy savings in one place on a database. The operation of it is relatively easy, and she can scale much, much faster. Next slide. On this slide is a video that will really summarize everything I've said about cooling as a service. Go ahead and play it.
The planet is becoming warmer. Population and economy are growing, while the demand for cooling is rising. Opting for a cooling system, you might consider an inexpensive one, but those come with a hidden price tag. Higher operation costs, high electricity consumption, frequent breakdowns, and the need for repairs. In this sense, modern cooling technology is less expensive because its life cycle cost is lower. Besides, innovative cooling systems provide higher indoor air quality and improved productivity. So how can you access a high-quality cooling system without straining your budget? That's simple. Don't buy one. Just use cooling as a service. You do not invest and manufacturers remain owners of their equipment. You only pay a monthly fee for every metered unit of cooling. This fee includes maintenance, repair, and running costs like electricity and water. So you just pay for your actual use. It is the provider's interest to install the most efficient technology and to offer optimal operation and maintenance. This approach is called cooling as a service.
Thank you. Right. I hope that video did a better job than my explanation. But yeah, so on the next slide, I'll talk about how that works. Okay, so the rough framework here, there's obviously a lot of detail behind this, but just the rough framework is that you ultimately sit with a manufacturer, or OEM as we call it, original equipment manufacturer, and you sit with the financier in between the end user and the manufacturer. Sometimes the financier is an independent institution. Sometimes the financier is part of the manufacturer, one business. And what essentially happens is the manufacturer, as I said, retains ownership of the equipment, just sells the cooling to the end user. The end user then pays a tariff, dollar per kilowatt of cooling used, to the financier, and the financier makes sure that the OEM is reimbursed for that. So that's roughly the architecture. Why is this beneficial? Why does this work? Because the economic incentives is lined up such that the OEM is there for a long-term partnership with the customer, and the customer gets long-term benefits of a partner who's with them that provides them efficient cooling over the long term and helps them to transition from one unit to the next, ultimately generating scale. So what we see on the manufacturing side is that they are forced to actually make the equipment more efficient, because the more efficient the equipment is, the more profitable it is for them. So they want to make sure that the cost of running this equipment, because now it's no longer equipment that they're selling to somebody else, it is their equipment. So they've got to make sure that the equipment runs most efficiently because the bill is theirs now. So there's built-in efficiency that comes with that, higher profitability if they make sure that the equipment is efficient. They've got a long-term contract with the customer, which means annuity income for them. It's a recurring model, so they can renew contracts with the customer, and they basically have a secured relationship with our property developer. So when she wants to go to the next building, she automatically involves them in her boardroom conversations, and she talks to them about the next building. So there's recurring relationships for the manufacturer. And on the end user side, she gets the immediate environmental benefits of reduced emissions via natural refrigerants, and of course, the highest efficiency cost per kilowatt of cooling sold to her. So she can go and get that credit finance that Luiza spoke about earlier as well. So she's got increased operational focus as well, so she can focus on a property portfolio while she knows that her partner is making sure that the cooling systems is functioning optimally. Of course, I said the life cycle cost of owning a system is also much better, because she's no longer doesn't have that on her balance sheet. It sits with somebody else's balance sheet. And of course, no capital outlay at all. She doesn't have to fork out a couple of £1 million for the new project. She can focus on taking the capital that she has and deploying into actually buying brick and mortar, the next building, which is what her business is about. So that's roughly the architecture and how that works. There's various models with various tariff structures, single tariff structures, double tariff structures, and all sorts of detail behind that. But I thought I'd keep it simple enough just to explain the architecture of what that would look like. Next slide. Okay, so I'll end with an example. This is a chiller project that we actually commissioned this week. It's two R290 chillers that we've put in to replace some legacy R22 chillers on a public hospital. And again here, it was in combination with a DFI that actually did a demonstration project, or we implemented a demonstration project, and what we've done here is we've overinvested in terms of technology for the customer. So instrumentation, visibility, dashboards, metering equipment, over and above the requirements for the demonstration project. And our thoughts here was that we want to make sure that this end user, this hospital, would be able to scale after the demonstration project. So should they, like in our previous example of our property owner, should they want to go from one chiller unit for one ward to the next ward and start changing over their fleets one by one, the servitization platform is set up for them to easily go from demonstration to the next instrument of scale through servitization. So yeah, I thought I'd just include a practical example of an actual unit that we're busy installing in Johannesburg, South Africa, for a public hospital there. And I think to conclude, for us, we think servitization is an appropriate tool because it's really engineered to have partnership on the ground and de-risk the customer, take the risk away from the end user and take the complexity away from the end user. And we believe that those are the factors that often causes end users not to go past demonstration projects. And so if we can reduce complexity and reduce the risk there and have partnership on the ground in the long term with them, we believe that's a model that can actually start seeing end users go from one project to the next and to the next and to the next. So yeah, servitization, it's out there, it's happening. Assad and them have supported that in India and various places. We're doing it in South Africa. We're doing it, on the continent. We're busy taking it to Europe as well. So yeah, servitization is here. We believe it's an actual tool to help scale natural refrigerants into this market, and we believe it can transform markets. Thank you very much.
Thank you very much, Samuel, and thank you so much for taking us into the world of your business owner and show us how to free her hands from complexity. Thank you so much for your presentation, and thank you once again to Luiza and Assad. And now it's the time to come to your questions. So I see that we have one question with kind of a lot of thumbs, and I'm going to start with that question, reminding you that now is your chance to go through the chat and pick the question you would like me to hand to our session by giving your favorite question a thumb up, or just write a new question telling us to whom it is, or if you want to, you can join us on the stage, and for doing so, just raise your virtual hand like this, and we will come to you in a second. Okay, so let us start with a question to you. Let me see where it is. There it is. So it's for Samuel. We're going to start with Samuel. So big question for cooling as a service seems to be how to measure cooling delivered. Might be practical for a chilled water system, but very difficult for a DX system. Chilled water systems have inherent efficiency disadvantages and no incentive to reducing the cooling load, though. For example, hybrid cooling. Samuel, is it possible to give a brief answer to that huge question?
It is. Thank you. It's an excellent question. Yeah, so clearly much easier to do metered cooling on a chilled water system because you can measure the flow of chilled water that you're supplying to an end user. As the questionnaire did mention that it's more difficult on a DX system and more difficult even on a multiplex system. With this, I'm proud to announce that we've built the world's first cooling meter. So we measure cooling in real time. And essentially the short answer is we plot ourselves on the phase diagram, on the pH diagram of the refrigerant, and we build a digital twin. So we can model what the cooling should be for a plant before it's even built. And then when we have the actual the physical asset being built, then we compare the two and we can see where they are. But short answer is we can, because we've built one.
Yeah, thank you very much. Next question is for you, Assad, from Mark. Given this massive 7 times explosion in demand, how can international climate finance pivot from small pilot grants to massive institutional risk mitigation facilities that allow African developers to leapfrog legacy cooling and standardize green infrastructure at scale?
Thank you, Julie. Question to ask, and it's the direction that we have to go. I tried to discuss some of it very briefly in the slides, but we could have a separate follow-up discussion on that. But let me just summarize it on three major points that comes to mind. First, we need to pool the risk. Creation of RSF facilities, risk-sharing facilities, deploying guarantee funds, guarantee facilities, and basically first loss facilities that the financial institutions, they feel confident and comfortable enough to go into this space through creation of these platforms. IFC and MIGA, and the World Bank Group in general, as well as other development financial institutions, they could be an excellent partner in devising such funds. And also the size really matters here. These facilities should be hundreds of millions of dollars. And that's point number one. The second point is standardization at the country level. Luiza discussed the taxonomies, and this is a very important step that we need to take. Also, adoption of minimum efficiency performance standards, as well as some other labeling that we require to move forward. For example, Kenya discussed that, Nigeria adopted it last year, as well as Ghana. So this is going to send a signal market that for the developers, that they're financing a regulated market. It's not a dumping ground of old and outdated technology. And that's not the competition here in the market, but the market is regulated and we are complying with these standards. And finally, aggregation. Aggregation has been a major obstacle in some of these markets, and Samuel can speak more for his experience as well, maybe in this context. There are these pockets of services offered, but the market needs also aggregation, in particular for CAS, for cooling as a service providers. And if we can prove, or if we can bring it to a bankable or investable scale, let me very briefly, Julie, at this point, the institutional investment minimum on account thresholds sometimes require for certain economies. Again, this is not a gold standard that it's not the same in every country, but depending on the size of the economy, the demand, and so on and so forth. So they have minimum on account thresholds. Most of these innovators and adopters, they have not matured enough, or they have not reached a level of investment demand or the market size that they're operating in that is of interest for most of these institutional investors. So we need to aggregate that, but also aggregation on the demand side, that what is happening in which value chain and what sector we're targeting. So if we package both of these and we bring it to financial institutions, then it will be a very appealing deal for the financial institutions. And the way for us to also make it more attractive is also to offer the first loss. That look, we have an RSF, we have a guarantee facility, or we are building you something that is going to cover the first loss. And this is the aggregated market. And the regulators, they have already provided a regulated market infrastructure. So we can bring all of these together. But a really good question. Thank you.
Yeah, thank you. Thank you very much. Luiza, we have a question for you in the chat. I'm going to read it out, and I have to make sure that I am not too fast for the translation to follow up when I read out the question. The Australian taxonomy has a GWP of 675 limit in your example. And this looks more like a way of phasing in R32 than R290. do you have plans to reduce the GWP limit to support R290?
That is actually a really good question, and shows me that one of my points on the last slide is correct. We have very few taxonomies, if not none at all, being ambitious enough to look at R290. We have almost 50 taxonomies worldwide, so a lot of regions and countries have developed their taxonomies, and cooling is the most ambitious cooling is also not found in there yet, which is really highlighting the need to enter this technical knowledge on cooling into these taxonomy processes, which means exchange with the regulator. A lot of countries have a sustainable finance initiative by the regulators. So how to, and the question is, how can we get the technical knowledge in there, because it's required in there in order to focus on green cooling and have that as a part of how we look at buildings, right? And embed it in the wider building picture. As Assad had said, it's a puzzle piece inside a big building, and it's not that puzzle piece is at the moment not reflective. So I cannot answer the question directly because I don't write the taxonomies. I work with banks and companies and real estate companies in using the taxonomies. So we consult them. We don't develop the taxonomies, but I can only invite you, especially as you are in official functions, if you are in official functions, to look for that connection to your local or regional taxonomy.
Yeah, thank you. Okay, so dear audience, dear participants, now is your chance to enter our virtual stage and ask your question directly. Just show me your hand. I will find you in our list, call out your name, and then you will be unmuted and can ask your question directly. And I am going to take another look at the chat, and maybe dear speakers of our finance session, there is something you learned from another presentation you just had you would like to point out or add just a tiny little question. I will give you a moment to think about that and go to the chat and read out another question to you, Samuel. So, who pays for the maintenance of cooling systems under a servitization model? Is the manufacturer? Is it the manufacturer since they own it? And regarding long-term use, is there a cap on the total amount of fees that can be collected, like 1.5 or 2 times the system's total cost, for example, from users?
Yeah, good question, long one. The second part I just probably have to think about, but the first part, who pays for the maintenance? So the customer pays for the maintenance, but the OEM or the manufacturer carries the risk of the maintenance. In other words, if something breaks or equipment breaks or it fails prematurely, all that cost goes on the OEM. The customer pays a flat fee for the maintenance. So it's basically like an insurance fee that they pay. So they don't get the headache of the ups and downs of maintenance. So they exonerated from that, pay a fee, and whatever happens on the other side, the contractor is responsible for. So in essence, the end user pays for it, but the contractor carries the risk for failure of equipment on maintenance. The second part of the question was, is there a cap on fees collected? So I would say no. It depends on the model. In our model, we've got what we call a composite fee structure. So we've got a maintenance fee component, which is I've just explained. It's a single line fee that the customer pays, and we take the risk on equipment failure. But then we've got a consumption fee, which really tracks as the customer uses cooling. So if cooling goes up, that's the consumption they're paying. If cooling comes down, that's the consumption they're paying. So the pay-as-you-go aspect really goes with how they use cooling. So if they use a lot of cooling, they pay for a lot of cooling. But you can also set up models where you incentivize customers that the more cooling they use, the cheaper you make your rates. That's just, you know, depending how you set the model up. But short answer is there isn't a cap on how much you collect. The fees is directly linked to how the customer uses the cooling.
Okay, yeah, thank you very much. So, you know why I really like the Green Cooling Summit? It's because we bring together different stakeholders and we really like you to connect, okay? So, dear audience in the chat, feel free to connect to the participants, and we will share all the presentations after the summit, and you do have the contact info of all our speakers on the slides. And I have a very big last question for you, Luiza, and I have to ask you to keep it really short. I don't know if it's even possible. And then I would like to hand over to you, Samuel and Assad, to maybe give us a goodbye and like what you take home from this session. So, Luiza, the question is, can you let us know how and who is deciding to develop and implement a green finance taxonomy for a country or region?
I actually have a very quick answer for that. You will be happy, Julika, because in my preparation for today, I've looked at lists for taxonomies worldwide, and there's a World Bank report that I've linked into the chat that lists a lot of taxonomies worldwide, I think 47 of them. And in that table, it also lists the lead agency. So the agency in that country responsible for developing the taxonomy that may help you to find the right organization to get in touch with to get all the cooling knowledge that we have in the room into the sustainable taxonomies.
Thank you so much, Luiza, for providing the link. I see it in the chat. And Samuel, just 1-2 sentences. What do you take home from that session that we have had today?
Thanks, Julika. Yeah, for me, I'm encouraged, and I hope everybody on the call as well, that the technologies are always developing, and the idea of us getting together on one call is to see how do we take those technologies and actually get them deployed on the ground. And it seems to me that the people in this room have thought about the finance, which is the most important thing, which Assad mentioned, which is that conduit that gets us there and gets it on the ground. And I think there's exciting developments in the finance space. So I hope everyone's encouraged and can reach out and find some help.
Thank you so much. Assad, what is it for you?
There are many things. On the last question that was asked, that was one of the biggest takeaways, that we are thinking in the right direction, that we have done the pilot, private sector has been in the forefront of it, innovation, adoption. Now it's time, or maybe this decade is the time for us to scale up. And that scaling up requires joining forces and meeting like this, the summit, to both increase awareness, inform each other on what we're doing, but also the flexibility that we are showing. So R290 is working. The model exists. Let's bring them together. And last point in my presentation, there's a link for IFC cooling finance taxonomies. It was yesterday, an event. I provided the link in the presentation. If anyone is interested to learn more about IFC products, they can also visit.
Thank you so much. And Luiza, what do you take home from this session?
I take home that we have some work to do in translating the technicalities of green cooling for the financial sector in the taxonomies included there as part of the puzzle to sustainable buildings, especially becoming so much more important with climate change adaptation also. Get those technical informations into there so that the banks and the financial sector can know, okay, this is sustainable or not sustainable, and so they can decide where to send their capital.
Perfect. Thank you all so much for your presentations, insights, and for your questions. we will now enter our break and let's be back. It's getting difficult. Let's say at 4:50 CEST time, okay? So we are going to write it down in the chat. It's like 12 minutes break, and then we will proceed with our summit.